So this is going to be the first time you've ever solved an exponential or a logarithmic equation. And the first step that you need to do is just rewrite it and see if that helps. So for example, here, if I have 5 to the x equals 56, you could rewrite it if you want. So let's do that. So this is going to be log base 5 of 56 equals x. And we actually can do that on our graphing calculators. Shall I teach you? Grab them up. Okay. It just keeps dying.
No.
I don't know. I'm gonna have to get new batteries, but I have to do it on this first. Okay, so first of all, can you guys all identify where the log is on your calculator? Okay, so where'd it go? So if you go down to see the log button right here, it actually doesn't have a number at all. And so this is actually a 10. So you cannot use this. You have to find a different log where you can put in little things. So let's just go ahead and try to search for it. I know it's in here somewhere. First person that finds it gets a point on their test. There's a couple places you can search for it. If you click on math, I'm just going to try to find something that says log. Oop, I found it. Anyone else find it? Yeah, where was it? Speak louder, I can't hear you.
It says math, and then
Yep.
go to number
It's log base.
A.
Good, okay, so you're gonna click math. Okay, there's no other point there.
What on me?
Well, you know,
I didn't want it.
no, I don't wanna give you it anymore. Alright, so scroll all the way down so I'm gonna show you again. You click on math, and then scroll all the way down until you can find something that says log base.
Mine doesn't have it.
I think you might have a ghetto calculator. Okay, press that. And then you have a 5, and then you change that to 56. And it gives you your answer, 2.5 roughly. I'm going to show you that again. You click on math, and then you scroll all the way down until you hit the log. Click on that, and then you're just putting in your 5 and your 56. So what does that really mean? And for those of you that don't have a calculator that does that, I certainly would let you borrow my calculator on a quiz or something. This actually means that we found the number that 5 to the 2.5 is equal to 556. We haven't been able to do that other than just guessing before. So go ahead and try that. 5 to the 2.6, sorry, what was it, 2.5? So if we do 5 to the power of 2.50109116, you see you get really close to 56. And the reason it's not exact is because there's an infinite number of numbers here, but it's still really close. All right, let me go back. So we found out that x is equal to roughly 2.5 on the first one. And we did that by converting this into a log and then throwing that in our graphing calculator. All right, this next one, we're going to go from a log to an exponential equation. So I'm going to go something like this. So this says x plus 1 squared equals what?
16.
Yeah. And I should have the x plus 1 in parentheses. So all I've done is rewrite it. Well, what number squared gives me 16?
4.
4. 4 times 4 is 16. So this whole thing right here has to be 4. So what does x equal to? X equals 3. Because that would be 3 plus 1 is 4, and 4 squared is 16. So there's not like one way to do these. It's just kind of rewrite it and then try to figure it out. And the ones that I'm going to give you today are actually going to be much easier than this. But I did think I'd just introduce you to this. Okay, on this problem here, I'm going to rewrite this as 7 squared equals 3x minus 2. Well, what is 7 squared?
49.
Thank you very much. Okay, so now I'm just going to solve this equation like you would in Algebra 1. How do I get rid of the minus 2? So I get 51 equals 3x. This is 3 times x, so how do I get rid of the 3 times x? Divide by 3. 3's disappear, and I'm left with my final answer of x equals 51 over 3. Feeling it? Like I said, these are kind of more challenge problems than anything, but they're nice to see. We're going to cover more of this in pre-calc if you take pre-calc next year.
Can we not answer it like divided by 51 divided by 3, or it's having a fraction?
I like it better as a fraction. Are you saying compared to like a decimal?
It's like if you do 51 divided by 3.
Oh. It's 16?
17.
Oh, then I like 17 better. Did you know that in your head? Did you just out pizza the Hut? So, are you okay, lady? You're like purple. I didn't realize it was that embarrassing. I have to Google later what I just said. All right. When working with logs, if you ever get stuck, just try rewriting the problem in exponential form. Is it inappropriate what I said?
No. It's so random.
Conversely, which means the opposite, if you're ever given an exponential equation, you can just rewrite the problem as a log. So it's like, okay, whatever it is, rewrite it as the other thing, and then it helps you solve. Those are our challenge problems. So try this one on your own for me, please. Log base 6 of x equals 2. Ignore the fact that it says now do. Alright, so you should have rewritten this as an exponential equation. This becomes 6 squared equals x. Well, this is 36 equals x. How'd we do? Nice. Alright. This next one is going to be really scary. I'm going to say evaluate log base 7, sorry if you can't see that, log base 7 of 7 squared. And we're going to let that be equal to x. I'm going to be so proud of you if you can get this on your own, but try this on your own. See if you can solve for x. I'd be really proud of you if you can do it in your head.
Really?
you do it in your head, Esmeralda?
I did half of it. I mean, I just wrote down the equation. I put 7x equals 4.
So the answer is 2, and I start by drawing my e, so I get 7 to the x power, 7 to the x equals 7 squared. So these two numbers are exactly the same, so these two numbers should be exactly the same. So x equals 2. Is that okay? Now, what you need to start being able to do is discovering some patterns here. What do you think, and feel free to guess, how could I not know this and be like a 4th grader who came in and was like, oh, you can do this and the answer is that? Like, where do we see the answer here? The answer is 2. So the answer is 2 here. So what do you think you can do with these two things? Rhymes with Rosset route. Rhymes with Rosset route. Add them? No. What rhymes with what rhymes with Ross them route? Cross them out. Yeah, you could go like this. If you have a number here that matches a number here, you can cross them out, and this whole answer is 2. And the reason why is because of this. And the other reason is because they're inverses. Okay, how about this one? Let me make that bigger. Whoa, I kind of really went for it. Go ahead and try to evaluate this, set this equal to x. So the first step that you should have done is recognize that this is an exponent, so we can transform this into a log. So this should have been log base 4 of x. Log base 4 of x is equal to this thing right here. This is really important for today's homework. Everyone listen right now. If you have the same log with the same base, what do you think is true about these two things? They're the same. So here we would have x is equal to 16. Now again, let's say that 4th grader comes in and gets the answer of 16 without knowing anything about logs. What do you think they did with a 4 raised to the power of log base 4? Rhymes with Rancelet route. Cross them out. So you're just left with 16. And this is only true if that number 4 matches that number 4. So that's a little bit of a trick. Definitely much more relevant in pre-calculus than here. I'm kind of showing you the high level stuff and then we're going to go down a little bit. So is there a shortcut? Yes, we've discussed them. If you have b raised to the power of log base b, these cancel and you're just left with x. Again, if you have log base b raised to the b, these cancel and you're just left with x. You can see how that happened over here and how that happened right here. All right, go ahead and get that down.